everyone, welcome to the Theorem, a channel specializing in biology, algebra, and geometry, along with some horrible comedy. You're watching episode 1. Everyone, meet Square Dot. This is our math assistant. No, you have to tell the math pun. Fine. Why was it hard for the Square agents to make a plan? They couldn't figure out the right angle. It's horrible. I know. This is the Theorem, and today's lesson is parallel and perpendicular lines. So, before we begin, what exactly is a line? Well, a line is basically composed of points going forever in opposite directions. I still don't get it. To elaborate, I want you to think about a row of square dots. Why are we making clones of myself? Just listen. All these dots are all straight, right? Yes, and they're horizontal, meaning that it's going left to right or right to left. Depending on how you look at it, both work. Good. Now I want you to think about these dots going in these two directions forever. You're giving me nightmares. You're telling me that my clones are going forever? What? That's a line, and lines can be vertical, which is up and down, or diagonal. While there are different lines for today's lesson, you only need to know this. So, why do we need lines, and where can we find lines in the world? Lines are very useful for measurement, statistics, and art. You need lines if you want to construct shapes like a square. You can also use lines to study data and analyze it, like on a graph. In art, lines are useful if you're constructing geometric artwork, like drawing shapes. Lines can also be seen in the fashion industry, like stripes. Now, in the world of math, there are two important lines that you need to know: parallel and perpendicular lines. Often, people will give lines names with either a single letter or two letters. So you'll find people using these symbols to express whether lines are parallel or perpendicular, like line WX is parallel to line YZ, or line segment, which is for another time, EF is perpendicular to line segment JK. What? I don't get this. What is this? Parallel, perpendicular, perpendicular. I don't get this. Okay, so parallel lines are basically lines that will never meet, never intersect, never touch, never make contact. Kind of like quarantine. Parallel lines are everywhere, whether you like it or not. Square dot. Parallel lines are in shapes, such as U, square dot. What do I have to do with parallel lines? Look, can I play video games now? I do not get this math lesson. Are you always this annoying? Look, we have to talk about perpendicular lines. What are perpendicular lines? Perpendicular lines are lines that intersect and meet at 90 degrees. What? Okay, that tiny square. They make that tiny square when you see a right angle, like in a right triangle, that tiny square to signify that there's a right angle. Oh. Everyone, look at square dot and notice her sides. Square dot is a square made up of 4 sides and 2 pairs of parallel sides and 4 perpendicular intersections. Parallel lines are the lines that will never meet. On square dot's red sides, these are considered parallel because if they were to go forever into the unknown, they would never meet with each other. If you look at square dot's blue sides, you'll notice that her blue sides will never meet as well with each other. Now look at square dot's top left corner. As you can see, and I'm not the best artist, I tried to draw square dot straight, but as you can see, the blue and red lines are meeting. This is perpendicular. They both meet and make a sharp 90-degree angle, or the tiny square you see for right angles. So, let me get this straight. Parallel lines, and when there's 2 of them, they are called a pair, but as long as they never touch each other, they will always be parallel. And perpendicular lines are 2 lines that meet and make the tiny square called a right angle. Basically, parallel lines can go in any direction as well as perpendicular lines, but as long as they follow these rules, they will always be classified as parallel or perpendicular lines. And this also applies to line segments, but that's for another time. So, how can we use parallel and perpendicular lines in the world of math? Let's look at our coordinate plane, and you'll notice I plotted 4 equations. So, what do you notice about them? They have the same slopes and different y-intercepts? Yes, so these lines are considered parallel because they do have the same slopes, but they have different y-intercepts. What was slope and y-intercept again? Okay, so slope is basically the steepness of a line, and the y-intercept is where the line touches what value it touches on the y-axis. But basically, the key idea you need to get from this is that parallel lines are going to have the same slope. The slope is the number that's being multiplied by the x, and that's going to be in another video. So moving on to perpendicular lines. So these lines are perpendicular. Do you know why? Because of their slopes? Yes, their slopes. What about their slopes? What about their slopes? IDK. Their slopes are opposite reciprocals. What's that? 2 and negative 1/2 are opposite reciprocals. A reciprocal is basically the flipped version of a number, and when a number is multiplied by its reciprocal, it gives you 1. But if I multiply 2 and negative 1/2, I get negative 1. Oh! Opposite like in signs. Yes. So if two lines, regardless of their y-intercept, have opposite reciprocals, they are perpendicular? Yes. What happens if it's like, for example, x plus 1 or negative x plus 1? While 1 is a wonky weird one, considering how the opposite reciprocal of 1 is just negative 1, they would still be perpendicular. What about 0? 0 slopes, which is basically like just flat horizontal, are perpendicular to undefined slopes. The undefined slope is like that straight vertical line that just goes down or up, depending on how you look at it. While it may be easy to just look at a graph or a coordinate plane and say, oh, these lines are parallel or perpendicular, you have to be careful because it may appear that way, but it doesn't make it right. So by measuring their slopes, you can tell if it's really parallel if they have the same slopes, or if they'll make a right angle if they have opposite reciprocals, or if they don't have either, they'll just touch one way or another. How would I make my own parallel and perpendicular line? That will be in our video on linear lines and the slope formula, and others. Darn it. Here is a quick recap on our lesson. So, lines go forever and can be in any type like horizontal, vertical, diagonal. Parallel lines have the same slopes and they never intersect, meet, whatever you want to say it as. Perpendicular lines have opposite flipped reciprocals and they make a right angle. This is the bio theorem. We specialize in algebra, geometry, and biology.